Hello and welcome back. In today's lesson, we'll be taking a look at how we can get laser scan data from a surveyor and prep it and get it ready for use within Revit. I have here an example of data that you might receive from an actual surveyor. It's in an AutoCAD file, so we're back in AutoCAD, and I wanted to point out a couple things in this file. The first thing that we'll take a look at is we've got circles that represent the common vertical piles on the structure. We also have, and it may be hard to see on your screen, we also have points that represent the slanted columns or angled piles. And this is data that you might commonly find being given to you from a surveyor. Oftentimes, however, there's a lot more information within the drawing. So I'm going to show you a couple of useful tips that allows you to select or filter data and be able to bring it into your specific file. Probably the easiest thing that you would want to do is first identify the layers that are in use in the file. In ours, it's rather easy because we only have 3 layers that we're dealing with: lower scan and upper scan. However, the drawing that you get may have many layers, and so what I typically recommend people do is there's a command on your layer panel called layer isolate. It's got several layers with an arrow next to it, and when you click that tool, all you need to do is click on an object that lives on a layer. You can pick objects that live on different layers as well at the same time inside the same command. And by doing so, after selecting those objects and hitting enter, those will be the only layers left visible in the drawing. Every other layer will be turned off. You can see here that it turned off layer 0 and left lower scan and upper scan active. Now the reason that I want to isolate these layers is we need to get the surveyor's data into our file that we're optimizing for use within Revit. Now these circles, if you look at your properties palette, show that they have a center Z value of 1, meaning it's at 1 foot above 0 elevation. Same thing for these points. These points have elevations as well. The red point is at 1, and the green point is at 14, and it's on a layer called upper scan. And commonly you'll find data given to you from surveyors with it already at the correct elevation, even though they may have graphically identified what that elevation is. This is good. If it isn't already at the elevation you need it, you would likely want to move that property to be at the correct elevation, where you would just select the object on properties, type in the value that you need, and hit enter. Now the next step that we want to do is we want to place circles at the centers of these points. So I'll start by ensuring that I've got my lower scan level selected, and I'll start the circle command. And there's a special object snap. If you hold down Control and right click, you can choose Node. And then left click on that red dot, which is a point. And if you take your mouse to the right and type the number 1 and hit enter, that'll place a circle at with its center at that point. Decided that I don't want to have a circle with a diameter of 1 or a radius of 1. I want to have a radius of 0.5 or 6 inches. So I'm going to draw that again. Control right click, choose node, pick the point, and type 0.5. You'll see that the circle that was placed at that node is approximately the same size as the other red circles already in the file. Now to place other circles at the other points, you could use the copy command. So we'll choose copy. It wants you to pick the base point. So we'll shift right click, pick the center of the circle, and again shift right click and choose node. And we'll continue to place red circles at each of these nodes. Now you could also, down at the bottom, right click on your snap selection and activate the node object snap. And that will allow you to continue to place circles but not have to fire up the shortcut menu. There. The other thing that you'll want to do is make sure that these circles have the correct Z value, and in this case the center Z is listed as being at 1, which is good. By placing them on the object snap of the node, they picked up the elevation that they needed to be at. Next, we'll set the upper scan layer current by choosing our drop down and selecting it from the list. And again, we'll make another circle on the green node this time, and again with a radius of 0.5. And again, we'll copy this, you may have to zoom in and zoom out a few times to get that finished. Now, like in the previous videos, you could watch me doing the same thing over on the right hand side. However, we've got a file that you can open called 04B piles, where I've already finished placing each of those circles on both sides. Now, what you'll want to do is you're going to want to take this data and get it into our file that has the pier outline already in it. Probably the easiest way to do that is simply select the piles from this drawing and press Control-C on your keyboard. That copies the data to your clipboard, and then you can switch over to the drawing that has the pier outline. And this one we've called 04 piles placed. We want to use a special paste function. So if you go back to your Home tab on your ribbon, drop down Clipboard, drop down Paste, and choose Paste to Original Coordinates. This works because the surveyor's content is sent to us using the same coordinate system that we've set up our file with. Now that we have this data within our pier outline, we can take this file and attach it to our Revit project. Go ahead and save your file and switch over to Revit. Now here in Revit, we're going to open up a plan view. So here in the plan view called MLLW of our previous file that we were working with called 03 Site plus Pier Building, this is where we will link in our updated file. Go to your Insert tab. Let's check our Managed Links and see if we have any files to clear out, which we do. So select the previous one that you had attached and remove it. Click OK and choose to link a CAD file. Go ahead and choose the 04 piles placed. Again, you'll want to review your settings and make sure that you've got colors set to preserve, layers are set to all. Import units you want set to feet. Uncheck correct lines that are slightly off axis, And this is one that may puzzle you at first, but we're going to choose the option Auto by Shared Coordinates. If you recall in a previous lesson, we set up shared coordinates in this Revit project. Because we did that, we can bring DWG files into our Revit model, and they'll drop in where they need to be. Go ahead and hit Open, and we'll see that information drop in here within our view. If you're curious, you could also open top of existing pier, and if you zoom in close enough, you'll see some of those red circles that we left for the piles along the edge, just barely sticking out from the edge of our pier. So hopefully this helps you see a clear path of how to get survey data from AutoCAD, clean it up, and get it ready for linking into Revit. Thanks for watching, and when we come back next time, we'll take a look at placing some of these piles underneath the pier.